So in order to compute the probability of medium score, then you've got the same basic set of commands as before. So again, R is like a robot, so two explicit separate steps. First of all, compute the model. Second, summarize the results. So the names have to match. So the first medium1.glm has to match the thing that you apply the summary command to. Again, and just to repeat that the second generalized linear model object here, medium2.glm, must match what you call up in the summary command below as well. Just to recap, so the GLM command works as follows. So here you've got ylow is related to region, family is binomial, so you're telling her at this point that you want it to do a probability regression model, not a classical linear regression model, and you can specify to fit a probit model if you wish. Now, as you said before, these models can serve as a cross-check of each other in applications, and that would be important. For instance, if you were doing something like this for your dissertation, I've not always had the maturity and the training to appreciate this fully, but you should expect to have similar models giving you similar interpretations and numerically similar estimates on a practical data set. So for the logit model then, so same set of R commands as on the previous slide, and what we've done here is just pick out the T statistics, and again same rhyme, rhythm and reason and underlying logic as you've seen before here. It's the second row downwards that are the interesting parts of this table, and we're looking for the p-values in the final column of each row. Here all these p-values are bigger than 0.05, and indeed they are also bigger than 0.1, so nice and easy to interpret in this case. So all you would need for the assessment for this module would be no evidence, p bigger than 0.05, that the probability of awarding a medium score depends on the region. Okay, and that would be all you would need for the assessment for this module, just as simple an interpretation as that. And this is making sense from the underlying context, because remember we said that you've got three categories, so it should be possible to describe this system by two equations. So all the information for the system should be in the probability of awarding a high score or low score. There should be no regional effect found in terms of these probabilities of finding a medium score. Okay, so far so good. It looks like we're on the right track. So just as an extra check then, wanted to do the same analysis with the probit model. Again, similar models should give you similar answers and similar interpretations on a practical data set. So the same set of R commands that we've just seen, slide 3.14, give you a load of results. These are the T statistics that second row downwards, where the interesting part of the table is, and we're looking for the p-values in the final column of any of these. 0.05, they are not, so we get the same interpretation as before with the logit model. And again, in terms of the assessment on this module, you need the interpretation just as clean and as simple as this. No evidence, p bigger than 0.05, that the probability of awarding a medium score depends on the region. So we've got two things here that give us an indication that we're on the right lines here. Firstly, we've got no evidence of a regional effect, and we know from the wider context that the information in the system should be contained in the probability of obtaining a high score and a low score. There shouldn't be anything left in the medium score part, and we're getting the same answer here for the logit and the probit model. So as these similar models serve as a cross-check of each other, we can be confident that we're on the right lines. I wanted to say a bit now about generalized linear mixed models. Now, mixed is just a small English word, but it's actually a really complicated word when it comes to statistics. So what we've got here are two things called linear mixed models and generalized linear mixed models. Now the mixed term indicates correlation problems caused by the sampling structure, and this can get very hard very quickly. So you've got the same basic interpretation of previous models, but you need to account for correlations caused by repeat observations and the nature of the data collection. Now, the reason for doing this in this practical example is that you should get more precise estimates of the regional effect. So the interpretation of the model and calculations involving the fixed effects terms are essentially the same as before, okay, but it is more involved in terms of the model fitting. So we've got actually sort of two simple examples here, but these are from a professional problem, a real industrial problem, and we got the analysis published in a journal article last year. So what I wanted to try and do in this lecture, though it's not necessarily easy, is section 5 presents a professional standard solution to problem 1, and section 6 presents a professional standard solution to problem 2. So these are genuine, hard industrial problems with a professional standard analysis and a professional standard data set attached. In terms of the analysis and optional packages in R then, so if you want to fit a linear mixed effects model in R, the basic R package that you need is something called LME4. So these things are usually deliberately named, and here LME stands for linear mixed effects. And this really is the best part about R. You've got this very large, very vibrant online community that provides a lot of code and software packages, so this saves a lot of work. You don't have to go away and code this yourself, and these packages are free to upload and download. Okay, now it is just possible that these may work better on your personal laptop than the University of Bradford computer, although it didn't have any problems with this at the University of Bradford last year, and indeed this whole process of downloading these R packages has worked better at the University of Bradford than at other universities I've worked at. Okay, so that's as an aside then. So in R, to upload packages, what you need to do is packages, load packages, look for this thing here, LME4, and click OK. Now I think this LME4 is one of the fairly standard packages, so it might load automatically, but it is just possible you might have to use CRAN to look for this, and I just wanted to, in any case, describe the process of how you would load other non-standard packages from CRAN. So in order to see what package is available for download, what you need to do is go packages, load package, and if the package is not there, you have to download it from CRAN. So for this, what you have to do is go packages, install packages, choose a CRAN mirror, and it's better to choose the UK, the closer the better, London or Bristol, or wherever you are in the world. And I think there's been occasions where one of London or Bristol worked and the other one didn't, depending on whereabouts I was working in the country. Once you are on CRAN and you've selected a CRAN mirror, you should then be able to select and to see a long list of packages that are available for download. And really, I wanted to emphasize again, this online community, long list of written packages and other online resources is really the best thing about R. Okay, freely downloadable software and code, and lots of different packages for doing different analyses. Okay, you're not constrained by what somebody else has put in a software package for you. There's just such a wealth of available resources in R. It's almost like the World Cup of statistics and data analytics. So in other places I've worked, I've had some problems with the University Computer Network. I haven't had these problems at Bradford, though I did have these problems at previous places I've worked at. And I just wanted to say a bit more about how you download our packages. I suspect that this will work better on your personal laptop than it would do on a university computer. So on my work computer, standard packages load fine. On your personal computer, once you download R, you should be able to update the list of packages via the R repository CRAN. And again, you've got this active online community, which is probably about the best thing about R and really the best reason to use it, because there's just such a lot of resources that are readily available online. Depending on the privacy settings on PCs on university networks, it may not be possible to update packages directly. Now, as I said before, experience last year tells me this wasn't a problem at Bradford, but it was a problem at my former institution. Now, if you have this problem and you've got campus access and want to use a campus PC, the work around this is try and save the package code to a USB stick, and then you can use this option here, packages, install packages from local files. Now, this shouldn't be a problem, but it's a bit fiddly when you first do this, and I found this fiddly on my personal computer. So my suggestion would be bring your laptop into class and we'll see if we can get it working. Okay. So I wanted to go through then professional standard analysis of problem 1. So the analysis in R proceeds in 4 basic steps. So the first thing is you need to download this LME4 package, and then what you need to do is fit 2 separate linear mixed effects models. So firstly, you fit a model with no regional effect but correlation caused by repeated measures, and then what you have to do in the third step is fit a model with a regional effect but correlation caused by repeated measures. Okay, so in each case the natural comparison to make here is that you've got some correlation caused by, technical term is repeated measures. It just means that you've got people that observe the same hotel, and necessarily if you observe the same hotel, have the same experience as a guest, there's going to be some correlation caused by the fact you've been exposed to the same stimulus. Okay, and that's true even if there isn't a regional effect. So once you account for this correlation, you provide the most sensitive possible test of the regional effect, and then once you fit the models in steps 2 and 3, you can use the chi-square test to test for regional effect by testing which one of these models in step 2 or step 3 is best. And you do this using a chi-square test, which is technically a likelihood ratio test. In R then, so for step 2, so just call it something, the linear mixed effects regression. R stands for, it's not a trained company, it is a statistical model. And how this works, and this will be rating, is related to the fixed effect plus, and then this is the notation for the saying here is that you've got some correlation caused by the fact you've got repeat measurements from the same hotel, and there's just this thing here. Thing, it's just essentially a bit of our syntax. Put in here, remel equals false. Call it something slightly different, and again, this is a linear mixed effects regression model, hence the use of the term R. Rating, region, correlation caused by repeat measurements from the same hotel, and again, this remel equals false. LMER is linear mixed effects model. Rating is the y variable we're trying to explain, and the model divides into fixed effect bit, the usual regression bit, and a separate mixed effect bit, which is the extra correlation caused by repeat observations from the same hotel. And then what you have to do, the reason for this remel bit, is suppress the remel estimation method. So mixed effects problems are hard. So mixed is just a small word in English, but this is a complicated word in terms of statistics. Mixed effects problems are hard. The problem structure may be intricate depending on the complexity of the data set, how the data is being collected. This can be true with things like surveys, or if you've got a designed extraction of data from a spreadsheet. These things can get very complicated very quickly. In my simple example, all that you had was some correlation caused by the fact that these were repeat measurements from the same hotel, and this had a relatively simple algebraic form in R plus one given product. So this means there's an average rating associated with each product or hotel, irrespective of who reviews it, precisely because each reviewer is assumed to be exposed to the same stimulus. Okay, so this is a simple illustrative example. So these mixed effects models can get very hard very quickly, and you could almost write a whole lecture course just on these mixed effects models. Fortunately, this isn't that module. Okay, so this is a simple version of something that can get very, very complicated, but it is one that does stem from a practical industrial problem, and I did want to present professional standard analysis and proper data set.